Okay, in this video, we're going to look at this truss structure that has elements that are 1 meter apart at the base here and an angle of 60 degrees, and we have a load of 200 newtons at this point here, D. And we're asked to calculate the force in each of the members. Okay, so the first thing we need to do is work out what the reaction forces at A and E are. So to work out the reaction forces, we need to take the moments about A, for example. So we have 200 newtons by 1.5, because this distance here, that distance there, is 1.5 meters, minus the reaction here at E, or E, which is 200 by 1.5. So that, which is 2, so that gives us a reaction at E at 150 newtons. So if we have 150 newtons here, with 200 newtons coming down, that means there must be 50 newtons here. And we can get that by taking the moments about E also. Okay, so we have our two reaction forces at A and E, and now we can work out the different forces in each of the sections. Okay, so we're going to break up our truss into little sections, and we'll begin by looking at the forces here at joint A. So if we take the forces at A, so we have 50 newtons coming in, and we draw all the forces in tension. So you notice all of these are drawn in tension. So in tension means they're coming away from the joint. So we have FAB, FAC, and we were told that this angle here is 60 degrees. Okay, so I have both horizontal forces and vertical forces. So if I take the vertical forces first, so this force here can be composed of into two components. So we have this vertical component and this horizontal component. Okay, so we would say at the joint, the sum of the forces must equal to 0. So I have 50 plus FAB sine 60, this is a plus because it's heading in that direction, is equal to 0. If we rearrange that, then we'll say FAB is equal to minus 50 divided by the sine of 60 degrees, and that works out to be 57.7 newtons. So the minus sign here tells me that this joint is in compression. Okay, so if it's in compression, then the force is going into the joint, not away from the joint. So if we take the horizontal forces, then we have FAC, so it's going to the right, so this is going to be a positive value. And again, FAB here can be broken into two components. So it's vertical and it's horizontal. So when we do that, we can say that the horizontal force, as this is a negative value now because it's going to the left, is minus 57 cosine of 60 degrees plus FAC is equal to 0. And when we do that, we get a value of FAC is equal to 28.85 newtons, and that's in tension. Okay, so that's joint A. We now will have a look at joint B. So if I take the forces at B, again, we'll start with the vertical forces. So we know that this force AB was in compression, so that it's going into the joint. Okay, so if we write the sum of the forces, so we've FAB sine 60. That's this guy. So that's this or vertical component. That's FAB sine 60. That's that. Minus FBC sine 60. So That's this guy here. So it's a minus because this is coming down. And that should be equal to 0. And when we do that, we get a value of FBC of 57.7 newtons. Okay, so that's 57.7 newtons. We can then do the horizontal forces. So we're looking at the horizontal forces. So again, this is broken down into its horizontal component, and this is also broken down into its horizontal component. So we would say FAB cosine 60, so this is a positive value, plus FBC cosine 60, again it's positive because all going to the right, plus FBD, so this is our force FBD here now. They should all equal to 0. And when we do all that, we get a value of FBD is equal to minus 57.7 newtons. All right. The next port of call then will be joint C. So if we look at joint C, we draw a free body diagram. Again, we draw all the forces in tension. And we have some values. So we have FAC. So this was this value here. That was 28.85. FBC was 57.7. So that's what we have coming in, and we need to work out these forces here. So if we take the vertical forces first, so coming in, we have FBC sine 60. So this joint was in tension. So don't forget this was a tensile force. So if the section is in tension, then this is going to be like that. So you have 57.7 sine 60 plus FCD sine 60. Okay, so this is also, we assume this is to be in tension, is equal to 0. And we put in 57.7 for FBC, it's sine 60 minus FCD sine 60. So these will cancel and we'll get FCD is equal to minus 57.7 newtons. That means this is in compression. Okay, so there is our joint here now shown in compression. So it's like that. So if we want to do the horizontal forces, so what we have is, if we break this guy down, there's the horizontal component of that. We have this horizontal component, we have this horizontal component of FCD plus FCE. Okay, so it has a horizontal component that way. So we would say minus FAC, okay, because it's going to the left, minus FBC cosine 60, so that's this part of it here, minus FCD cosine 60, so that's this horizontal component here, plus FCE, because that's going into the right, is equal to 0. And when we do all of those, we get FCE is equal to 86.55 newtons in tension. Okay, finally then we will do joint D. And if we look at the forces at D, we have, well, FBD was a compressive force, so the force coming into the junction. We have 200 newtons coming down. We have FCD. Again, this was a compressive force, so it's going into the joint. And FDE, which we don't know. So if we take the forces at D, we have minus 200 plus FCD sine 60. Okay, so that force there can be constructed into its vertical component. minus FDE sine 60. So the vertical component of this force. So we have 200 plus 57.7 sine 60, because we calculated this to be 57.7. And when we do all of that, we get FDE is equal to minus 173.2 newtons. And now we have the forces on all the joints. Okay, the remaining joint here is E, but we already know that that's 1732 newtons in compression. And we already know FCE, we got that before because it's already calculated, and that was intention. So we can just do a check there, taking the forces at E. So at E, the vertical forces, we've 150 minus FDE sine 60. So that's this guy, the vertical component of that. And that should be equal to 0. So 150 minus 173 point sine 60, and that does indeed equal to 0. So they are our forces all resolved.